SOLIDWORKS provides a great deal of flexibility when defining planes and other reference geometry. However, it's not possible to write an equation that will directly control a plane's definition. If I open the Plane tool, notice in the Feature Manager I'm asked to select references to define the plane. While I can't write an equation to define a plane, I can use equations to define these references, which ultimately accomplishes the same thing. In this lesson, I'll show you how you can use equations to define the normal vector, and then create a plane normal to that vector at a point. The concepts I'm showing you here can be applied to create any kind of plane you need, in that you use equations to define the reference geometry, and then use the reference geometry to construct the feature. To begin, I'll start a new 3D sketch. Next, I'll go to Tools, Sketch Entities, and select Equation-Driven Curve. Now let's assume I want my direction vector to pass through the points 1, 2, 3, and 5, 7, 9. First, I'll do a bit of math to determine the vector between these 2 points. 5 minus 1 is 4, 7 minus 2 is 5, and 9 minus 3 is 6. That gives us our direction vector, 4, 5, 6. The parametric equation of a line is L of t is equal to P1, the first point, plus t times the direction vector. So, our line equation is 1 plus 4 t for x, 2 plus 5 t for y, and 3 plus 6 t in the z direction. And I'll have t go from 0 to 1. I'll click the green check, and the vector is created. Notice as I click on each of the endpoints of this vector, it does indeed pass perfectly through the points we wanted. You can see the points in the status bar down at the bottom of the screen. I can highlight the line and select the For Construction checkbox to convert this vector into construction geometry, and I can exit the 3D sketch. Now, I'll launch the Plane tool. I'll choose the vector I just created as my first reference, and choose Perpendicular as the end condition. For the second reference, I'll select the endpoint. This fully defines the plane, and when I click the green check, I get exactly the result I was looking for. You can use equations to locate points, or define offset distances, and essentially apply this same or similar techniques to create any kind of equation-driven planes you need.